Hello everyone, my name is Koundinya Gajulapalli. I'm a 9th grade student from Kendriya Vidyalaya Air Force Station IAPT, and I've been allowed to participate in InSpirQ 2025 with special permission from State President of IAPT, Dr. C.H. Madhusudan sir. And today I'll be presenting my theoretical framework, which I personally called cabinet theory, but it's formally titled a 5-dimensional geometric theory of time, gravity, and cyclic cosmology. It is archived on Zenodo by CERN. My ORC ID is 0009 0001 3510 1878. My work proposes a new way to think about time itself, not as a single universal parameter, but as if it were a stratified geometric structure. To deviate this theory from speculative philosophy, I've mathematically closed it with a well-defined action, constraint structure, and cosmological predictions as well. My motivation was quite simple. Many of the problems in modern physics persisted because we didn't lack equations, but we might have been using an incomplete notion of time itself. So the problem statement is that modern physics rests on two pillars, not one: general relativity and quantum field theory. Both of them are extraordinarily successful, but they are fundamentally incomplete at the level of time itself. In general relativity, time is part of a dynamical geometry, and in quantum theory, it's an external parameter. This mismatch becomes very critical in cosmology. The classical general relativity predicts an initial singularity where physical laws break down, and while inflation attempts to address this, but it introduces new scalar fields, fine-tuned potentials, and imposed initial conditions. At the same time, with this theory, problems such as vacuum energy divergence, matter-antimatter asymmetry, information loss, and the origin of cosmic structure remain unsolved or partially explained. A common assumption underlies almost all of these issues and all of these theories, that space-time has exactly only one temporal dimension. Our theory challenges this assumption. The central idea of our theory is that time is not singular but layered, with each fundamental quantum field evolving in its own intrinsic 3+1 dimensional spacetime and having its own internal time coordinate. Gravity, however, must not live within these intrinsic spacetimes, but must propagate through an additional extrinsic time-like dimension, which is denoted xi. This produces the 5-dimensional manifold with signature minus plus 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 minus, which contains two time-like directions denoted minus. This, however, does not mean the uncontrolled evolution in two times, which would lead to all sorts of problems such as CTCs and ghosts. The physical evolution in our theory is governed by a single Hamiltonian constraint, with xi acting as an ordering parameter for relational dynamics and not as an independent clock. The key consequence is temporal scaling. Intrinsic times are related to the extrinsic time through a geometric scaling factor. All particles must propagate locally at the speed of light in their own intrinsic times. This is of course hypothesized, but they appear massive and subluminar due to the differential temporal flow between the quantum fields. Gravitational effects such as time dilation, inertial mass, and cosmological expansion emerge as geometric consequences of temporal curvature and not as fundamental inputs in this theory. The gravitational action is derived from the first principles, requiring homomorphism invariance, ghost freedom, and second-order dynamics will obviously uniquely select a 5-dimensional f of r theory, which naturally produces a non-singular cosmological bounds. The key results in our theory were, first, that this theory enforces a zero total energy condition as an Noether identity and not as a tuning. The vacuum energy must cancel out geometrically, stabilizing the quantum vacuum. Second, the cosmological evolution is non-singular and cyclic. A smooth bounce must replace the Big Bang and must be driven purely by higher curvature geometry. No exotic matter or energy condition violation is required for this, as we have not encountered those while solving the equations. Third, the linear perturbations must obey a fully covariant 5-dimensional Mukhanov-Sasaki equation. The temporal scaling during contraction produces a nearly scale-invariant scalar spectrum without inflation, while tensor modes are naturally suppressed. This leads to a clear observational prediction, a low tensor to scalar ratio distinguishable from standard models. Despite the presence of two time-like directions, the theory remains unitary and goes free. The constraint reduction renders the Hamiltonian self-adjoint, and physical states always evolve relationally rather than with respect to an absolute time. Beyond cosmology, the framework offers geometric explanations for matter-antimatter asymmetry, thinking of them as flowing from opposite directions, dark matter as a temporarily decoupled sector, and information conservation in gravitational systems. The future scope of this theory is that it suggests that the primary obstacle to unifying gravity and quantum mechanics is not the quantization itself, but an incomplete temporal geometry. By extending time rather than space, our theory resolves the initial singularity. It stabilizes the vacuum, it preserves unitarity, all whilst reproducing the standard four-dimensional physics at late times, all within a single mathematically consistent framework. The predictions are of course falsifiable. Suppression of the primordial tensor modes and specific deviation from standard cosmological signatures provide clear observational tests. Whether nature would choose this theory and structure still remains an empirical question until such systems are made to test it, but the result is concrete. Extending temporal geometry would offer a viable and economic alternative to inflation and conventional quantum gravity approaches such as string theory and loop quantum gravity. Thank you for your time.